Today, we are diving into one of the biggest, most exciting shifts happening in medical technology, multimodal AI. We're going to break down exactly what that means, how it all works under the hood, and most importantly, why it is poised to completely reshape how we all practice medicine.
So let's just start with a really fundamental question. As clinicians, our brains are constantly synthesizing everything, right? We're taking in labs, imaging, the patient's story, our exam findings. But do the AI tools we have right now do the same thing? Well, the short answer is not really. And that gap, that's exactly what we're going to explore. To make this real, let's talk about a patient. Let's call her Mary. She comes in with pneumonia. Now, all the individual pieces of her story are there in the system. Her home meds, like Ramipril, her admission labs, which looked fine, but they're all in different silos. Nobody and no system is connecting the dots. And what happens? Her meds are continued, she develops an acute kidney injury, and that tips her into heart failure. It is a textbook and totally preventable case of how fragmented data can lead to real patient harm.
And Mary's story really highlights the core problem with most of the AI we use in medicine today. It's what you could call the unimodal ceiling. These are amazing tools, don't get me wrong, but they're built for one job using one kind of data. Think of an AI that only reads chest x-rays, or one that just looks at vitals for sepsis. They're powerful for sure, but they're only seeing one tiny sliver of the whole story. And right here, you can see the fundamental mismatch. Our thinking is holistic. The AI's is fragmented. We're constantly synthesizing all this diverse data while the AI is stuck in its single lane. This creates what researchers have termed a contextual ceiling. Basically, the point where the AI's usefulness just hits a wall because it lacks the full clinical picture that we build almost instinctively. So, the big question is, how do we smash through that ceiling? Well, the answer seems to be building AI that actually starts to mimic how a clinician thinks. And that, right there, is the promise of multimodal AI.
Okay, so here's the big idea in a nutshell. Multimodal AI, or MAI, doesn't just look at one thing. It's designed to fuse multiple, totally different data sources all at the same time. The goal is to build that holistic, context-aware picture of a patient that we've been talking about. It's basically trying to bake our own integrative reasoning right into the code.
And when we say diverse data, we really mean it. We're talking about combining everything from medical images and structured EHR data to complex genomic profiles and raw ECG signals. And what's absolutely crucial is that it can also understand unstructured clinical notes, the actual narrative, the story, which is so often the most important piece of the whole puzzle.
All right, so this all sounds great, but how does it actually work? I mean, how on earth does a computer combine a CT scan, a doctor's note, and a bunch of lab values? It's not magic, it's actually a pretty elegant step-by-step process.
It all follows this clear pipeline. First, you gather and clean up all the raw data. Then, you use special tools to translate each data type, the image, the text, the numbers, into a common mathematical language. But step 4, fusion, that's where the real breakthrough happens. This is the moment where all those separate streams are merged into one single unified picture. This allows the model to find these hidden connections that no single piece of data could ever reveal, before it finally gives you an output. Now, this isn't just a cool idea in a lab somewhere. The proof is already showing up in major clinical research. So let's look at a few really high-impact examples where multimodal AI is already blowing traditional methods out of the water. I mean, just look at this. Across completely different specialties, the results are seriously impressive. In oncology, combining imaging, path reports, and notes hit a 0.914 AUC for predicting therapy response. That is incredibly accurate. In orthopedics, mixing x-rays and EHR data predicted 30-day mortality with 84% accuracy. And in cardiology, as we're about to see, it's already leaving our classic risk scores in the dust. Let's just zoom in on that cardiology example for a second. There's a framework called Precog that pulled together imaging, genomics, and biomarkers. It achieved a predictive accuracy, or C-index, of 0.75. Now, to put that into perspective, the classic Framingham risk score that we all use, it clocks in at just 0.66 for the same group. That isn't a small improvement. That is a massive leap forward in our ability to predict disease. And that hip fracture model we mentioned, it's the perfect illustration of this power. The combined model's 84% accuracy wasn't just good, it was way better than what you could get from the images alone or the EHR data alone. It's the ultimate proof that, when it comes to data, the whole is truly greater than the sum of its parts. But, of course, it's not all smooth sailing.
While the potential here is absolutely enormous, we have to be really honest and clear-eyed about the challenges. Because when you have a technology this powerful, it brings its own unique and complex set of risks. So first, let's talk about a huge opportunity: tackling burnout. Think about AI scribes that can listen to a patient encounter and just generate the note for you. Studies are already showing these systems can slash documentation time by a third. That's a huge reduction in the daily cognitive load that wears so many of us down.
But here's the flip side. The very thing that makes these models so powerful, that fusion of all the data, is also what makes them so risky. See, when you weave together so many different inputs, figuring out why a model made a specific recommendation becomes incredibly hard.
And these are the big hurdles we absolutely have to clear. For instance, a little bit of bias from one data source can get amplified across the whole system, leading to dangerous conclusions. And as for explainability, it's a black box problem on steroids. And that's before we even get to the huge challenges around data privacy and the simple, practical nightmare of trying to plug these complex systems into our already fragmented hospital IT infrastructure. So with all that, where is this actually headed? What's the real vision for this tech in our clinics? Well, let's be crystal clear about one thing. The point is not, and never will be, to replace physicians.
The real vision here is one of augmentation. The goal is to build a collaborative partner, a co-pilot, if you will, that can handle and synthesize data on a scale that's just beyond human capability. This frees us up to do what only we can do: complex reasoning, showing empathy, and ultimately making that final clinical judgment.
And this all points toward a truly mind-bending future ambition: the digital twin. Just imagine creating a complete virtual replica of your patient, built from all of their data, that allows you to simulate treatments and predict how they'll respond before you ever give a single medication. That is the ultimate promise of precision medicine that this technology could finally unlock. And that brings us right back to where we started, but with a question for all of us. As this tech gets better and better, the central challenge isn't going to be about the AI itself. It's going to be about us, about how we as clinicians can thoughtfully, carefully, and safely weave these incredible tools into our daily work to augment and never replace our own clinical judgment.